right. Hopefully I won't bore you guys too much. I apologize. There's not a lot of graphics in this one. It is pretty much a expansion on the JavaOne conference I went to. Since I kind of gave it highlights of, what's coming and what's new with Java and kind of the community. This time I decided I wanted to basically really knuckle down and really talk about some of the new features in Java 9. So this is going to be still kind of high level. I don't have huge configuration examples or code examples for some of these yet. I have a funny feeling each one of these topics in and of themselves could be a presentation kind of all by themselves, or potential blog post on the particular topic. So I'm going to try and get through this. I might get done a little quickly. I might not. I'll try to get through this as painlessly as possible. There is a lot of information on these slides. I'm not going to really read a lot of the slides. I will provide the slide deck once we get this posted. It's just a lot of good information for you as to what these features are, and kind of a quick reference in case you run into a project for Java 9 and you just want to make sure that you're aware of what potential pitfalls or new features that you could use with your next application. So, with Java 9, what's new? Well, we have a boatload of new features. To start with, we're going to look at and kind of get a little deeper dive into the new versioning string schema that Java is going to, or has introduced. Technically, they're still kind of using the same naming convention. We're now on 1.9, but going into next year, they're going to switch over to the year, month, day naming schema. They've also introduced the G1 garbage collection is now the default garbage collection. We're also going to take a little bit deeper look into the deprecation of the Applet API, which I briefly mentioned in the JavaOne presentation. We're going to look at some of the highlights of the JavaFX and the CSS APIs that they've introduced. So since everything with Java 9 is now modules and Jigsaw, JavaFX had to also adapt and become module. And so they did that for both the UI controls and the CSS APIs. They've separated the layers. They've now also added a spin and wait hint to help with threading. This will be a neat little feature for some of you who may not have seen this. You may have accidentally done this in the past in other shapes or forms, but not really known what you were doing other than trying to do a pause. So this is actually a cool little feature we'll talk more about in a little bit. Java 9, hey, we finally get SHA-3 hash algorithms for encryption. About time. We'll talk about that some more. They've also introduced the HTTP2 client. We also now have HTML5 Javadocs. Yay, we don't have to look at those nasty old plain crappy APIs anymore. And we also have some platform logging APIs and services. These essentially will help you replace the log4j and SLF4j. So Java now has a clean logging API. So these are just the first batch we'll go through. So let's look at the new version string schema. So it's one of the smaller changes that they introduced with Java 9, but it's a significant change, especially if any of your applications or your continuous integration uses the Java versioning of the existing SDKs for your deployments. So some of the things you need to make sure you look at now is you need to make sure you follow the major, minor, and security conventions that they've introduced. So there's more information here. Next screen, though. So this is kind of the breakdown. So we've talked about versioning in the past when we talked about Git and we talked about how to tag and version your code. Essentially, this is still following those standards. It's just Java's finally gotten on the bandwidth and basically going to apply something that works and meets with everyone else's standards. So the major, of course, applies to a major release that contains significant new features. Again, this could be like a huge milestone rollout like Java 9, Java 8, Java 7, and so forth. Unfortunately, going forward into next year, your major is pretty much going to be the year. Minor increments for a minor update. These could be bug fixes, could be security fixes, or maintenance releases. Again, that will be the month with the way they're currently doing it. However, if you download like security patches or things like that, they'll still follow these patterns. Security, which will be the third one, basically any critical fixes or patches to security issues. And the fourth, which is what most people do, is just it's free version number. So you could do 1.9.0.b100, which could be like a beta release. Could be A for alpha release. You could it could basically be whatever you want to help describe the particular release. So if we apply this naming convention to what they currently have out, so if we did the long format of 190-b100, that meets with the new naming conventions. So you got your major, your minor, your security, and just some for descriptive. But the short version would still be Java 9. So it essentially just takes the minor version and makes it the significant naming if you were to go strip out some of the core features of the naming convention. APIs out there, you can use it to, if you repoint to your applications to apply this formatting, you'll be able to have your continuous integration, your Maven, or any of your other build scripts can actually pull the correct Java version going forward. JWone, now the default garbage collector. So with all these large databases, in-memory databases, smart databases like Oracle's doing, where your data that's not processed for long periods of time essentially gets rolled out to basically slower media formats. So if you have like a tape drive, your data can move all the way up to the tape drive. They started playing around with this way back in Java 8, or actually Java 7. It was officially released in Java 8, but it was still kind of in an alpha format, although it was primarily used on major mainframes, IBM servers, or Oracle servers. Well, they finally figured out that it works best pretty much anywhere, but primarily more for systems that have multi-processor machines and large amounts of memory. Although, if you're running your application locally on a desktop, you may still want to flip it back over to the traditional garbage collector. They're both still there, but by default, since most applications and the way the industry is going, we're dealing with more web-based applications, microservice applications, web services. So potentially, you're going to want to keep the JWone configured and hit the ground running. So it tends to meet garbage collection pause time goals, which is one of the main latency issues that we had with the old one. But essentially what JWone gives you is a larger capacity with, you can use your memory better, and it uses CPU processing more efficiently. So heap sizes up to 10 of the gigabytes or larger, with more than 50% of the Java heap occupied with live data. That's huge. If you switch back to the old garbage collector, you probably, if you're just doing a standalone app locally, you're probably going to get about the same results, maybe a little bit better. But on a large database system, if you switch to the older form, you're actually going to lose performance. You're actually, it's not going to optimize and use most of your memory. It's going to misuse the processors. So you're actually going to hurt yourself if you're not using JWone on those larger systems. a significant amount of fragmentation in the heap. So instead of everything being grouped together in like massive clusters, it's now fragmented across more clusters, which is kind of cool because by doing that, if it throws out a pause, it can actually clean up smaller chunks faster than trying to handle the larger heaps. More predictable pause times, so you don't have to wait as long. And you can also explicitly enable it by providing at the command line the -XX plus use G1 GC on the command line. Now that's if you want to explicitly do it. However, like I said, you can set up your systems to essentially already have this just by going to Java 9. You can also flip it by using the other command line, which I don't have here, to flip it back to the other garbage collector as well. Deprecation of the Applet API. We briefly talked about this with the JavaOne discussion, but the Applet API is going away. Not necessarily right now, maybe in the next release, but it may not. They're trying to sunset it as fast as they can. They're pretty much showing people now to either go write a standalone application, move over to JavaFX, or put it into some other form of application type. But get out of applets as fast as you can. Right now, they have set, so this is actually kind of interesting. So this, we'll discuss this a little bit more later, but they've added a now for removal method to the deprecation tag. So if you actually go look at the applet in the API, you'll see it's deprecated, and you'll see this additional method for removal is set to true. So in the very next, or very soon after the next major release, this will essentially be turned on, and it will be removed. Prepare for JavaFX UI controls and CSS APIs for modularization. So with the introduction of Java Jigsaw, and I guess I'm slightly out of order here because I talked about that in a couple slides, but I kind of wanted to talk about this after the applets because they are pushing people to use JavaFX or straight up applications. However, with the introduction of Java 9, the modular approach or Jigsaw breaks a lot of the typical mindset, and especially with JavaFX. This is because a lot of the APIs of JavaFX UI controls and the CSS functionality were not strongly encapsulated, so they were not protected. A lot of the internal APIs were open. So in order for people to make things present the way they wanted to on the screen, they had to go in and actually override some of the internal classes, which is very bad. And now that they've encapsulated everything and it's now strongly encapsulated and all these inner classes are now locked down, well, as soon as you switch to Java 9 and JavaFX, oops, everything's going to break. So what they've done initially is they are now giving you warnings. So with the forthcoming release of Java 9, strong boundaries between modules and Project Jigsaw. So developers will find that their code will no longer compile or run since the com.sun packages will no longer be accessible. And this doesn't just apply to JavaFX. This really applies to anything in Java 9, but it is more significantly with the JavaFX and some of the older J2EE and even networking classes. They found that some of the com classes for communication and whatnot and the net classes were being overwritten so people could actually write their own protocols to send information across the web or across servers. So this is their first step. So what did they add? Well, they've essentially created two new packages. So we've got a package for the UI controls and the skins, which is in the JavaFX screen control skin, and they've added a new class called CSS parser for parsing CSS style sheets. So you essentially have now split the layers from the one model that they had before to two. So now you have one where you can actually control all the elements and actions on the page, and then you have all your style sheets essentially now set up in a separate layer. So now you can create templates and style sheets a lot easier than you could before. And the CSS API is in the JavaFX CSS package, includes new support classes, including the CSS converter packages and parser. That's it for JavaFX. And then wait, so I thought this was actually kind of cool because I've actually had to apply this before in some other web applications I've worked on. So they've now added a thread on spin wait method. So it's essentially an empty method, but behind the scenes there is some processing that's being done that allows the thread class to handle the pauses and the compile compilation with the machine a lot faster and a lot better than you just kind of putting this little read and process event, which is essentially just a blank method here. So here, if you're waiting for an event, essentially you do, well, not notification received. Typically you'll do something like, hey, event received, just to show that it worked. Well, here, if you flip it over, you now do this thread on spin wait, which once it actually finishes processing, it'll kick back a lot faster than just doing this blank method for spinning. So this is actually something that was kind of cool and something that was new. So I was actually, I'm kind of looking forward to playing with this one a little bit. And especially if you think mobile, all those little load screens and that, essentially you could write this on the back end and do the same thing. So if you're waiting for something to load on the front end or communication, you could trigger this. Some other benefits, so the reaction time of the spin loop may be improved when this spin hint is used, reduces the thread-to-thread latencies. Which is kind of cool, especially on other systems and devices. The power consumption by the core or the hardware thread may be reduced. So this again is pushing to all that speed, improved speed, lower cost, lower power usage, which basically gives Oracle's new database servers kind of the edge, where they say that, hey, we can run a web service in like 2 seconds, whereas it'll take 8 seconds to run on AWS. So this gives you some additional speed and performance issues. We also now have the introduction of the SHA-3 hash algorithms. So I've done encryption in the past. I know Rob's done some encryption in the past. SHA-2 has kind of been hitting the butt for a while, where it's like, okay, we kind of need to get to the next standard like sooner than later. And unfortunately, Java has taken a little longer to get here than we wanted. But essentially, this is a stronger form of encryption than we had before. Just to give you an idea, here's a little spreadsheet from Wikipedia that gives you kind of an overview of where things are at. So SHA-2, we started to see that there was some length and extension attack issues starting to show up with SHA-2s. We did get the SHA-15 with Java. I believe that was with Java 7, mid-Java 7, Java 8. Which is still strong encryption. But as you can see, we're starting to slip a little bit with the red here. So it was just time, hey, let's get to SHA-3. Everything's in the green, a lot more block sizes for encryption, and you're more secure. So they'll start using this for a while, and then sooner or later they'll move on to the next standard. But we're finally there. We can finally strongly encrypt our application. HTTP client, the original HTTP handling API in Java was written way back in HT1.1. It was agnostic. It supported many types of connections using the same API, except it never kept up with the evolution of HTTP. HTTP kind of left it in the dust years ago, and it's just we've been struggling to keep up with the standards and having our web applications be supported and approved for HTTP2. So now we have a clean New API that's been added to Java 9 to support HTTP 2. The new API handles HTTP connections through three distinct classes. We now have the HTTP client, the HTTP request, and the HTTP response, which we essentially have had these before, but now they are HTTP 2 standard. So you can now handle and create the sending of the request, receiving the request, and sending the request to the client. Construct request to be sent back via the client, and the response request and sent back to java.net has now introduced the HTTP client class as well as the HTTP request. So before we actually had HTTP request and HTTP response. So now they've introduced the new HTTP client class. Little note down here. Unfortunately, they say they released 2.0 except it's actually in an incubator release, but they went ahead and wrapped it in anyway because they think it's done enough, and with the rapid release that they're going to be doing with release schedule being every 6 months, they feel they'll have it probably all the kinks worked out in the next release or two. So just be forewarned, if you start using it, you might run into some issues. Just open up some bug tickets on the Open JDK, and hopefully they'll get to it quickly. Javadoc. So, yay, we're finally HTML5. We now have all the typical HTML5 markups. We can now have graphics. You now have the x.link feature. It's an update to check documentation comments for common errors like spelling, markup issues. So cool, we now have actually an error checker for our Javadoc builders. One of the things, let's see, let me jump out of the presentation for just a moment, and let me show you what the Javadocs looked like previously. So here's Java 8. This is before the new HTML5 standard. So they have some CSS. They did add some things to make it nice and clean, look nicer, prettier. You have your old tree formats. You have indexes. You can do frames, no frames. Except, looking for something or trying to find a class, you typically had to go up here. You had to do all classes, and then you could do a search for like AWT, and then you could go find or AWT, and then you could go find all the classes for AWT. It worked. It just, if you had anything internal, you didn't really see it. Under the new Javadoc standard, it's a little cleaner. So I can still go to frames. One of the new features I love is we now have a search box. You can now straight up search for what you want. So AWT, boom. There's all the packages, types, everything that possibly has AWT. You don't have to hunt and peck anymore or just go searching through the frames or the API. It's right there. It's easy to see. Another feature, let's see, Java RMI. So here's another feature. So with the module implementation with Jigsaw, when you build Javadocs, any dependency you have to your class is now generated with a graph. So you can now actually click through to it's looking still. I had it working at JavaOne, but again, they're doing continuous builds. You could actually just, before, click out to like Java Base or Java XML, and it would jump you to the specific API. But it's not letting me do that for some reason. But anyway, all your dependencies will show up in a graph. So if you have multiple dependencies, you'll see a larger graph here with all your modal dependencies. So this is something else that's new. And again, the search is new, CSS. and I like it. It's a lot cleaner. It's going to make creating Javadocs a lot more fun and more useful. Oh yeah, improved structural HTML5, headers, footers, nav, and the search box. Platform logging and API services. Long overdue. Long overdue. I don't know how many times I have struggled with logging in the late 90s, early 2000s, even in 2010. We had Log4j from Apache, except Log4j had some issues. If you started including load balancers and having multiple servers try to write to the same log file, you basically ran into whoever got access to the file first, locked the file, and they were the ones writing to the file. Along came to the rescue of that is SLF4j, which could now allow concurrent logging to your log file from multiple servers. But why do we really need all these third-party APIs for logging? Shouldn't Java do that for us? Well, now it does. With Java 9, the SDK classes now have a pipeline to push messages through the interface called logger. So they kept the typical logger, which Log4j and SLF4j use, but it's now built in the JavaUtil logging API. Oh, I'm sorry. It's defined and used in the Java base, not on the JavaUtil logging API. That's because the logging API, the original logging API, was the one that Log4j initially used, which was what caused our problem. So they pulled everything back up to the base and applied the SLF4j logic. So we now have a platform logger. Benefits of the platform logger. Well, reduce the dependency of Java logging modules, again, like SLF4j, Log4j, or any other third parties you're using. It also fixes some of the bootstrapping issues, so your classes can log messages before the log consumer is initialized. Again, that was the problem with the Log4j issue, which SLF4j fixed. So if the log consumer grabbed it, they owned it, and therefore no one else could write to the file. And lastly, by default, log messages via the JavaUtil logging API when the Java logging model is present. If you want to include the logging, you just have to include the Java logging as a dependency. But since it's in the Java base, I don't believe you have to include that modal for any of your projects. I think it's there inherently. All right, here's some more features. There was a boatload, so I tried to cherry pick some of the ones I thought were kind of critical or key to some of the transitions from Java 7, Java 8 to Java 9. Some more features. We got the multi-resolution images, so you can now have multiple images at different resolutions for essentially different web browsers. Or in a sense, if you're creating an application that will work on multiple devices, you need to make sure that your images scale correctly to that particular device. So Java now has the ability of doing a multi-resolution images where you essentially define one image object with multiple resolutions, so it can pull the correct one for the for the device that you're running on. The Modular JDK, I've talked about this multiple times, or referenced it multiple times. This is Jigsaw, the modular dependencies now of all your classes, the strong encapsulation of the Java 9 JDK and its correlation of JavaFX and some of the other libraries. JLinker kind of came out of the development of the Modular JDK, so this is a way for you to link to your different modules. Enhanced deprecation. So we now have a couple new methods for deprecating so that we can actually apply some more useful notations to our deprecations that will show up in our Javadocs. We now finally, I don't know why it took them so long, they did for everything else, but we now have private interface methods. So you can actually declare a private interface so that you can avoid duplication of core modules that are in some of the interface classes. So you can, like in a init, you can say, hey, private has to have a init. All of them pretty much do the same thing, but you're not sharing that out. So when you define the interface, it's not necessarily always there, but the init is present, it's just not referenceable. Multi-class release jars. Oh, unfortunately, we need this. You now have the capacity to create or to modify the jar meta files to distinguish if you're deploying to Java 8 or Java 9. I actually have some more features coming on that in a different discussion because that's going to be a longer discussion. One of the cool things which this helps lead to is we can essentially get rid of the class path. We can actually configure our Java applications, our web applications, to know exactly what Java runtime it needs when it runs. Next, we have convenience factory methods for collections. So they've added some additional methods to help us with our lists and maps. Process API updates. So there's another process class that was added. Filter incoming serialization of data. This helps you with streams or like streaming data across the web. So let's dive deeper into the multi-resolution images. So again, this is the new API. This is to help you package multiple resolution images into a single, into an array so that you can reference one object set for multiple devices. So the Java AWT graphics class gets variants from a multi-resolution image based on the current display DPI matrix. So this basically means that your device resolution, it will pull the correct image out of the class array that you built for your device. Basic operations are retrieve a resolution-specific image and retrieve all the variants in the image. This is what it looks like. So you do a buffered image, resolution variance, give it some variance. Multi-resolution image, BMR image equals new base multi-resolution image, base index. So essentially you're building your array or you're building a list. So you give it an index 0 and you give it its resolution variance. Then you take the image, text RB image, BMR image, get resolution variance, 16 by 16, and assess the same. So image should be the same. So text RB image should match resolution variant 3. So essentially, how we're pointing this here should map to this here. So if we put the same image in this block here, and then we define this, when it goes and compares the two, it should see the same thing. So it's a very interesting, cool little class. Kind of excited to see how it plays out because now we don't have to go create a bazillion freaking image resolutions. You could actually define one image and set the resolutions in here. Or if you do have to create multiple image sizes, image sets, you can define them all here in this configuration and then just call the BMR image and pass in the index based on the resolution variable. The Modular JDK. Oh, this guy. Unfortunately, it was necessary. The current JDK was too big, too bulky, too open, not really strongly encapsulated, and it was a mess. In order to fix Java and allow it to grow and continue to expand and be scalable in the future, they had to fix it. So by doing so, Java 9 breaks the model that we are 100% backwards compatible. Going from Java 8 to Java 9, your code may break. Chances are it will break. That's okay. You can make it work. You just have to figure out how Jigsaw works. It's still a little tricky, still a little not fully user-friendly. It will take a little bit of work to get there, but I'll probably do a full deep dive on that at another time. Just know you can do it, but it will be necessary to do it. So the goals of the module was to make it easier for developers to construct and maintain libraries in large applications. Sure, wasn't Java already built for that? It was, except due to the fact that some of the core Sun classes and internal classes of Java were essentially open, people did go in and override and extend their own libraries based off the core libraries that they weren't supposed to. So in order to maintain libraries, started becoming a problem. So that had to be fixed. Improve and secure the maintainability of the Java SE platform. Done. They've locked down the core libraries. It's now secure. Breaks things. Implementation in general, the SDK in particular, done. Enable improved application performance. That is key. By locking things down and making things more modular, what you now can do is when you go to deploy or share your libraries, you only have to pull in the dependencies you need and export or share your particular class packages with other people. So you don't have to share everything. So what's cool about that is when it goes at compile time, it's only going to pull those individual pieces out of those modules and combine them together at compile time. So instead of having a very bloated, completed package that gets pushed around, so like all these third-party libraries that we're including in our code, like POI for Microsoft Excel configuration, or like PDF Box if you want to do PDF files. Their full library is currently being embedded with your project and being redeployed. With this new approach, it basically takes out just the pieces you need and compiles them and puts them all together. So your code base or your jars or your executables are a lot smaller, a lot more lightweight, faster to run. Modular JAR files also contain additional modal description bar. Okay, so in order to do modules, you now have to create a module class file, which is kind of like the INF or the web INF directory of web applications. So this particular class is going to essentially tell the compiler what to pull in and what to share out. So you control the access and the dependencies with the requires and exports commands, and all non-exported packages are essentially encapsulated in the model by default. So they're not necessarily shared, but if you pull in the module, they will still be there so that they can be called and used. So for example, we have module bar. So here's our modal description. If we want to export any of our internal packages, so say, for example, I have com.foo.bar and com.foo.util, only bar is going to be accessible by any other modules that include my module within their projects. However, oh, wait, foo.bar actually needs other bar before it can actually run. So you have to require com.other.bar, which pulls in the dependencies from another module. Pretty straightforward. However, the caveat you're going to run into, especially with Java 9 and some third-party dependencies, is unless your third-party dependencies have done this and done it correctly, when you try to pull in their third-party libraries initially, if they have not done this, your project will break and your dependencies will be broken until those third-party dependencies fix them for Java 9. So it's just something to be cautious about, and just be aware of that when you're trying to switch over. With that comes the Java linker, or jlink. This is a tool that helps you assemble and optimize the modules for runtime images. So it essentially looks like this. Jlink, you pass in a set of options, you set the module path, where's the module, and you add in multiple modules that you want to combine together. and then it will link them all together and create a custom image or a set of modules for you to deploy. I'll get into more on this in another deeper dive, but we still have a lot to cover. So enhanced deprecation. So along with the deprecation of the applet, they added 2 new methods for deprecating. You now have the for removal, and since for removal is essentially to specify whether this API is intended to be removed in a future release or not. The default is false when it's not specified. So as of right now, the applet class is now set for removal is true. The other one that's kind of interesting is the since. So this string parameter specifies the version at which the API became deprecated. So we now have the for removal set to true, and since it's now 1.9 for the applet class, but if it's left empty, the default value is just an empty string. So it's just, again, the typical at since and the Javadoc tag. So inside the Javadoc, you just use at since or at for removal. Private interface methods. So these are just private methods, just like any other class remove methods. These interfaces have the following benefits. No need to write duplicate code, hence more code reusability. And we get to choose which methods implementations to expose to our clients. So this particular example here, I briefly mentioned it before, the init method. Especially when you're dealing with web applications or even mobile applications, init is typically a common method that is included in most classes. However, we don't necessarily put it in the interface. Well, in this case now, we can actually define it in the interface and set it as private. It's part of the public. It's part of the interface that we can pass around, but it is not exposed to the public API. So if I actually go look at the Javadocs for the API, it will not show the private void in it. Multi-release jar files, pretty straightforward here. You now have, what you do is you essentially go into the jar files meta-inf file and you modify the configuration. So you can now say versions, 9, multi-release, and you tell it the helper class. If you define this, you have to then set up your multi-release, helper class, and main class. If you don't do this, and you just leave this blank, it's just going to call these particular classes here. So if I were actually to run this application or run this jar file here in Java 8, it would ignore this helper class, and it would run these. So these are your default classes that you want it to run, and then this is the specific class you want to run when you're running Java 9. You could also set up for version 8, 7, 6. Typically, though, this is only going to work 9 forward. If you want to specifically define anything for 9. Now, with the multi-versions of 9 coming out, this is going to be more useful and can allow for more continuous integration if you're dealing with clients that are still on the older versions. So you could actually set it up to have 2 versions. You could have one for Java 8, one for Java 9. Convenience factory methods for collections, lists, and sets. There's also some additional changes for maps that we'll get to in just a second. So here, lists and sets now have a new of method. So you can now do a list of, the list mutable list of. So now allows you to create an empty or non-empty immutable list of sets. So this is how you can define an empty immutable list. Whoops. Or you can actually define a full list of immutables. So you can actually do a list of 1, 2, 3. So this is new. This is cool. So now you can actually quickly build an immutable list, whereas before you had to actually go new hash map, new list, or new array list. So this just is a quick way to get you where you needed to be. And I don't know why this wasn't implemented a long time ago. So maps. Maps actually gives us two. So we get a map of, which you then can define the empty immutable map here is going to be an empty map, and then a non-empty map example. So you do map of key value pairs, and then when you actually go to look at the values, it's going to be 2, 2, 3, 3, 1, 1. Process API updates. So they've given us the Improve the Process API for controlling and managing operating system processes. This was, I'm not entirely sure where this came from or what the necessarily what the need was for it, because there are some good third-party libraries, but that being said, they were third-party libraries. So they decided to pull this in, so now you can actually get more concurrent information about the processes that are actually being handled. So just like in Linux, where you can like go get the process ID, or with Windows, where you can get the PID, you can now do that straight from the Java code. Filter incoming serialization of data. So this is leading us to the new stream interface. So allowing incoming streams of object serialization data to be filtered in order to improve both security and robustness. So we kind of needed this since everything's going to like Netflix, some of the other streaming ones. You got YouTube, Hulu. So if you want to stream a lot of information or stream a lot of video data, they needed to improve the robustness of the serialization class. So we now have 4 new methods. We have the drop while, the take while, which if the first packet is dropped, it will return null. So take while actually requires everything to come in correctly, but as soon as something drops, it will drop. Of nullable, you can check to see if it's a nullable stream. And then the other method was actually applied to the iterate class, or the iterate method, allowing us to precipitate when to stop an iteration. And finally, I'm not going to get into these at all on this particular presentation, but I wanted to bring them up. I will probably do another dive later with these, plus some additional other ones, but these are just some good ones to be aware of. You have the completable future API improvements, the dive-in operators for anonymous interclasses, so you can actually specify strings, integers of interclasses. You can actually type define them. Option class improvements, try with resource improvements, so you can actually do some new tweaks with the try catch blocks, or just do a straight up try block. JShell, I'm saving that one for its own either nugget or kind of standalone presentation, but JShell is now a real-time runtime environment that you can kick off from the console and actually be in a like Java shell, like a Perl shell, but you can type in Java commands real-time, just quickly hash out how can I do something, work it out, and then copy and paste it into your code. So that one's really cool and a lot of fun, because once you start playing with it and you really start to see what you can do with it, you will probably lose about an hour. Stack walking API, so you can now walk through your different stacks. Compact strings, kind of abbreviation strings, we'll get that more in detail later, and enhanced method handling. So at this point, does anyone have any questions?
I do have some questions.
Okay.
Okay, I got a few questions for you. So when is this gonna be released? That's the first question.
It's out now.
It's out now.
It's out now.
So how big is this change? I mean, how is it affecting projects that are already in production? Or
it's huge. At JavaOne, the conception was no one is on Java 9 yet from pre-existing projects. New projects have already begun in Java 9. So anyone kind of jump starting something new, they've already gone ahead and started with Java 9. With that being said, I didn't mention it here, but I did mention it in the last presentation. So because of this kind of conundrum where they had to break things to make Java 9 continue to make Java great, they will not sunset the core Java 8 for at least another year, maybe year and a half. So they've extended support for that for another year. But they do want people to get to Java 9. You can go to Java 9, certain things will break. You will get some messaging saying, hey, this is broken, but they're soft errors for now. And by soft errors, it will tell you it's an error, but it will still continue to run it kind of as if it was on Java 8. But you're basically taking a risk. There will be some caveats, some side effects that they just don't know what's going to happen. So they do stress to start learning Jigsaw and start applying it now.
Okay, so will companies have options like maybe stick to Java 8 code? And the reason why I'm asking, like for instance, my workplace we're using Windows, we're still using 7. Is it?
Yep, and that's actually a good point. So one of the things as I was putting this together, I ran across a little pie chart, and unfortunately I didn't copy it when I saw it, and I lost it. But from what I saw, 40% or 47% of the community is using Java 8. So, and then of that, you have about 40% still on Java 7, and then a small sliver on Java 9, and the rest is pre-7. So there's been a long hesitation for moving from Java 7 to Java 8, and now we've got 9. So Oracle understands there's going to be a hesitation to go to 9, but they're trying to push people faster to 9, and they're hoping to get there by doing the continuous deployments every 6 months, having new features constantly rolled out where people want to get to 9 faster. So those that are in 8 will probably adapt to 9 faster. Those in 7 may be screwed and may look at other technologies or are going to have to bite the bullet and really look at their legacy software and say, hey, we need to get with the times. We need to figure out how to get from where we're at to where we need to be.
All right, those are my questions.
Anyone else? All right, well, if there's no more questions for coming to the presentation, if you have any questions, comments, shoot us a line at info@developerner.com or just drop a line on the blog once it gets posted.